Here is SimTech Soild-CIM software working directly from an AutoCAD 3D Solid or a solid that has been imported into AutoCAD from any one of a number of types of solid file formats. We can import from many sources now, including SolidWorks, ProEngineer, CATIA, Parasolids, Step Files, Rhino. All of those are available as imports directly inside of the AutoCAD software, and we get our 3D solid that you see on the screen here. This is an assembly, and it is just AutoCAD 3D solids at this point. All right, doesn't matter where the source came from, any 3D solid modeling package, we can import the data. And now I'm going to use the Soild-CIM software to lay those parts out and nest them for me. We have an extra button on the toolbar right inside the AutoCAD system that lets me select my solids, and the feature recognition process begins. The parts are analyzed which side should face up based on the side that has the most machining on it. Now we do feature recognition on all sides of the parts, but one side is going to face up. If there's machining on both sides, we'll add that as a checkbox in the cut list, so the AutoCAD can then go and do two-sided machining or two-sided nesting if the parts have machining on both sides. Now this assembly has some pins and some other geometry that's outside the scope of routing. My settings will automatically remove those from the list. So one of the nice features here, the parts are recognized with just one click, L for layout. It instantly lays all the parts out flat. So that is the power of the program right there. You can see the pins and the extra geometry that is ignored. And here's my parts and my part geometry, and I've got features recognized here. Datas are extended beyond the edge of the part. If I start moving some stuff around, you'll see the individual parts. Here's the outside geometry. Here's the dado. There's the actual 3D solid. That's what I wanted to get at there. And here you can see the results that were feature recognized there. Okay, so in a shaded mode, you can see the solid, and you can see the geometry that was created from that solid. In all cases, it's the same. There's the features that were recognized from that solid. Features, they're on different layers. It's geometry on different layers. Any CAM system can now cut that geometry on different layers, and they also have a thickness built in as well, so that the AutoCAD toolpath generator will generate the toolpath based on the thickness of the geometry. I'm going to undo a few steps here and move the part back as an assembly and show you some of the other features that are built into the Soild-CIM program. It has a very nice feature here called the cut list. And what the cut list is it's a PDF file that has all the parts named and their material and a picture of the part. So here's the name of the part, the size, the picture of it, and the material, and there's if it has the back side. So once I have a cut list like this, I have those individual part numbers. What the part numbers allow me to do, you can see the part numbers here. Another feature in the the Soild-CIM program is to expand all the parts out. Now this is a visualization feature that lets you expand them or blow them out so that you can do an exploded view on the model. And the part numbers are listed on each part still as they're exploded out, so it helps to assemble the model as well. You can see the part numbers on there. Those are going to be the numbers that we also generate when we make the NC code. So the main thing the Soild-CIM does is it exports this information to the CSV file, to a cut list. Once I have all my parts exported, it's just one more click to go ahead and make the NC code for those. I can exit out of AutoCAD, and I have a folder now with that date and time. There's all my individual parts. I can right-click on that cut list and cut with AutoCAD automation, and again, it's completely automated. All the parts in that assembly were laid flat, feature recognized. A cut list was generated with the part name, the material, and the quantity of each part. So it does see duplicates as well, and it will increase the quantities on those. Then with a simple right click on a CSV file or any cut list, we can import that and run it directly through the AutoCAD automation program. The layers that the geometry is on, that determines the type of toolpath. So there was some stuff on layer counterbore and drilling. Those are cut with drilling operations. Here you can see some complex geometry that's cut and routed at different levels. All the individual parts are processed, and a program is generated for each individual part, and then the nesting will commence as well. All the parts of the same material will be nested together. The Soild-CIM program greatly reduces the number of steps to go from any kind of 3D solid assembly to nested-based or single-part programs. The number of steps it saves is significant. A typical user would open up a 3D model, and he would have to make drawing views or a top view of the part, and then he would have to process the part and make toolpaths for it kind of interactively, unless he wants to take and put geometry on different layers, which would be an extra step. See? The Soild-CIM does all that for you. It puts the geometry on different layers, it recognizes the features, and it builds that cut list. So the number of steps is significant. Anybody working with 3D solids can clearly see that layout step saves a huge amount of time for them. You can also add your own 2D drawings to these jobs as well. AutoCAD cuts not only the 3D solids, but of course it cuts 2D geometry, DWG files, DXF files, even parametric macros that are part of AutoCAD as well. We can work with any of that type of geometry. You can add those right to these same jobs. Things like dados are automatically extended beyond the edge of the part so that you get a full cutout on dados. We use our helical entry. We're ramping in with a helical motion that reduces your tool wear and much less wear on your spindle bearings by ramping the tool in the material. Here's our nesting process beginning now. Parts are nested. And the layout is saved as an AutoCAD drawing. Again, we're using tool stay down nesting, which is one of the AutoCAD advanced nesting features that dramatically reduces your cycle time by keeping the tool down and connecting from part to part without lifting up. Now there was a few different materials in here, so I had most of my parts nested on that 3/4 material. Now here's some other ones that were on a thinner material. And in just a few seconds here, we went from an AutoCAD 3D assembled model to nested parts in just a few minutes with very little user intervention and very few clicks. This is Simtek's Soild-CIM software to go from an Inventor assembly model directly to nested-based and single-part programs for any CNC router or point-to-point. I've opened up an Inventor assembly model in Inventor 2012, and when the model is open, the Simtek Soild-CIM software is an extra button right inside the Inventor Environments toolbar. So the assembly you see on the screen there, with one click, will take the individual parts and do what we call feature recognition. The parts are automatically recognized and converted into individual part files, and we build what's called a CSV file. This is a cut list It's a comma delimited file. So that entire process has been completed. I now have programs for each of my individual parts in that assembly. Here's the folder with today's date and time. There's all the individual parts using the part names from Inventor. And I have a CSV file which has my name, material, and quantity. And we can go with one more right click, cut with AutoCAD. The part is imported and the parts are cut and nested. So it's literally just 2 clicks to go from the Inventor model all the way through to cutting and nesting the parts. Now I'm going to get programs for each of the individual parts. I'm also going to get the programs nested together, the parts nested, so we generate programs for single parts and for nested sheets. That's useful if a part moves or falls. I have the program ready to run the single part by itself. The processing that takes over now is automatic. This is what's going on here is our layer to knowledge is cutting the parts out using the AutoCAD automation suite. Each part is processed. An Excel spreadsheet pops up that reports the cycle time for each part. Horizontal routing, horizontal drilling is taking place as well, so the single parts have the programs for the horizontal machining. We do full 6-side feature recognition. So all sides of the parts are recognized. The toolpaths are generated automatically. The single part programs are sequenced and connected together. A report for each program is generated. And the next thing that's about to happen is the parts will be nested based on their different materials. So there was a few different materials on this example. Here they are nested out in a layout. I'm using what's called stay down nesting, which reduces cycle time up to 20% by keeping the tool down and connecting part to part without lifting up. Each of the materials gets nested as a scrap cut. If there's extra material left over, that is cut as a piece of scrap, optionally inventoried and used in the next job. AutoCAD has that rolling scrap manager built in as well. So in just a few minutes, we went from the Inventor assembly to nested parts and single part programs in 2 clicks at about 2 minutes time. I open my results and there's the results with the same name as the Inventor model. I've got my nested sheets available as PDF files so I can view my nests and they can be sent to any printer. I've got the entire G-code file programs on here as well. You can double click on the G-code file and it shows in our toolpath verification program. There's a simulation, and this is the tool stay down nest as the parts connect to one part to the next without lifting up. And we do have a programmable overlap on there too, so your parts are good for edge banding. There's the scrap cut. This is the shaded toolpath simulation that comes with the AutoCAD program. Also in there is our individual parts. All the individual parts have their little cycle report here that gives us the machining time, the tools that were used to cut the part, and how many inches of tools, how many inches off each tool was used. You plug in your tooling costs. It adds some other variables like machine-related downtime and handling and personal fatigue and setup time. So this spreadsheet is available to you to give you an accurate cycle time for single parts. We also have the single part programs available. So you've got the G-code file for the single part in there, as well as the G-code file for the nested sheets. The nested sheets are saved as drawing files that you can open up, and here from the drawing file you can see the 3D solids are still in there. You can see the shaded representation of the solids. They came right from Inventor, and the parts are feature recognized and all the toolpaths are generated. That's the AutoCAD with Soild-CIM automation directly from Inventor models to fully nested based parts and single part programs in just 2 clicks.